6.1.2, application of vectors in the plane. If you go back and think about what we've done in 6.1 part 1, so the main bulk of the notes, we talked about component form, right? We talked about magnitude or length of a vector. We talked about adding vectors. We talked about multiplying by a scalar. We practiced finding the unit vector. And then on Friday, we looked at that linear combination, right? So today, we get to talk about velocity. And I know you guys aren't in physics in this section. It's my morning class that has some people in physics. But velocity and vectors are a direct relationship here. So notice the definition up there. The velocity of a moving object is a vector because velocity has both magnitude and direction. We have talked about vectors having magnitude and direction, and velocity is a moving object with magnitude and direction. When we talk about magnitude, the magnitude of velocity is speed. So we will, in other words, when we start talking about speed in this problem, we're talking about the velocity. And then force is a vector's magnitude, which we're actually not going to talk about force because that would be down with either example 2 and or 3. And I am only looking at example 1. Okay? So let's look at example 1. A DC-10 jet aircraft is flying on a bearing of 65 degrees at 500 miles per hour. Find the component form of the velocity of the airplane. Now, notice what it says in parentheses, though. The bearing of the airplane is the angle that the line of travel makes with due north measured clockwise. So in all honesty, that's the confusing part of the problem, is how to measure. Because notice it says angle it measures with due north measured clockwise. Well, if we're talking measuring from due north, they're saying that due north is going to be 0. Where are we used to 0 being at? Yeah, we're talking 0 being east, right? I think 3 o'clock, but east is a valid reference here. And so that's the big thing here is being able to connect our unit circle, where 0 is at east or 3 o'clock, with the basic compass where they have 0 at north. Okay? So, I, of course, am going to start with a picture. Okay, so there is my arrow to represent north. The jet aircraft is flying on a bearing of 65 degrees. And notice what it says about a bearing. The bearing of an airplane is the angle that the line of travel makes with due north, measured clockwise. So where am I going to have that 65 degree angle at? If this is due north, measuring clockwise means I'm going to the right. See, that's the other thing. We're going the opposite direction from what we do on the unit circle, yes? So clockwise is going to the right. 65 degrees is going to be does that work? 65 degrees-ish? So that is 65 degrees. The key is I stopped before I got to what? 90, right? So if we go ahead and draw the 90 inks, we'll have to talk about it. There's your x-axis. There's your y-axis. But this angle right here that was 65 degrees from north represents our jet. And what else do we know about this jet? It had a speed of 500 miles per hour. Sounds a little on the fast side. Although for a jet, who knows, that could be slow. I really don't know a whole lot about the speeds of jets. So, okay. Now, this problem asked us to find the component form, yes? And if you go back to what we did on Friday, we talked about the horizontal and vertical components. Do you remember what we talked about on Friday with the horizontal and vertical components? How do we find them? Not that one. The one you're thinking about, the x minus x and y minus y, that's if we know two vectors. The absolute value of A, or not A, but A is the absolute value of the vector times the cosine of the angle, and B is uses sine. Does this sound familiar? So it was the magnitude or absolute value. Okay, so for the first component part is magnitude or absolute value of V times cosine of theta. And then for the second part, it's magnitude or absolute value of V times the sine of theta. And if you recall, those were my horizontal and vertical components. So, we're trying to find component form, which means we need those horizontal and vertical components. So if we're going to do that, absolute value of V, yes, we need to know the magnitude. Well, thoughts on magnitude here? Magnitude is the velocity. Do we know a velocity? And velocity is speed. So, magnitude of velocity is speed. We know it's speed, yes? The speed is given us 500 miles per hour. So guess what? You don't even have to do any math. The magnitude is 500. And that's because the magnitude of velocity is speed. Okay, so that means we know our absolute value of V, yes, that's magnitude. So absolute value of V will be 500 when we get to that part. And then what's the other piece of information we're going to have to know? What? We have to know our theta. Okay, so officially called the direction angle. Now, when we talk about direction angle, when we put an angle in with sine or cosine, we need to go back and think about the unit circle. Okay? If you go back and look at what we did last week, and it talks about direction angle, the direction angle of a vector V is the angle theta that the vector makes with the positive side of the x-axis. Okay, so we need not an angle in terms of the compass, where we started from north. We need an angle in terms of starting on the unit circle. So thoughts on what angle we're going to use here? Somebody said something quietly. I couldn't hear it though. Okay. And what does 65, taking 65 and subtracting it from 90, how's that going to help me? What's that give me? That gives me this right here. Yes? And is that the angle made with the x-axis? Yeah. Okay, so yes, that is what we want here. We want, based on 0 degrees being the typical unit circle, 0 degrees being east or 3 o'clock, we want to know that value there. So in this case, it's not that you always subtract it from 90. That's just where we are. In this case, we're going to use 90 minus 65, which is 25 degrees. So our direction angle, or in other words, theta, is going to be 25 degrees. Okay? So you're always going to want to figure out how far is your angle, this angle in question, from 0 based on the unit circle. So from here, how far is your angle? Okay, and I will caution you, we'll have to talk about the ones in homework. You don't want to think reference angle. Okay, it's tempting, but if we think reference angle, we're always going to get positive quadrant 1 answers, and we should have some negatives on these. Okay? Okay, can you find the component form now? We know absolute value of V, we know theta. So plug them in. In order to find the first part, or in other words, the A, absolute value of V, which what am I using for absolute value of V? 500 times cosine of 25 degrees. That is a calculator type problem, right? So 500 cosine 25. Oof, sorry, I've got to turn that light off. Got a big glare there. Times the sine of 25 degrees. Again, calculator problem. Don't miss a button on the calculator like I just did. That would have given me a wrong number. 211.31. Okay. With that in mind, guys, what is my component form? 453.15, comma, 211.31. Now, realize this component form, okay, this vector, first of all, hopefully that kind of makes sense there, that first of all, both numbers are positive, right? The horizontal, we're going right. The vertical, we're going up. So they're horizontal. This one right here represents what direction? What is our horizontal direction here? We're going to the right, which is what direction on a compass? East. So this 453, technically it's miles per hour, and that is 453 miles per hour in an eastward direction, easterly direction, however you want to say that there. And the 211.31, if that's my vertical component, that's going to be 211 miles per hour in a what? Northern? I don't know if the book uses this or what. I have northward written down. Maybe those were the book's words. I don't know. My morning class said northerly. Yes, same thing. Okay. Northern. However you want to put this. Okay. So the idea that this jet, there's two pieces to this component. It's going 453 miles in an eastward direction and 211 miles in a northward direction. Okay. And combining them together is that 500 miles per hour overall. Okay? Okay, 41 and 42 are similar to this. As I said, we'll have to talk a little bit about how the angles work. But I'll have you guys give those a try. So, when you are completely done with homework, the problems you should have done, page 464, 5 through 8, 13 through 20, 25 through 34, all originally given. And then also, if you missed Friday's add-on, it's 41 and 42. Okay? So grab your homework out. Hopefully you have it started. If not, you can be starting, I guess. Grab your homework out. And for those of you that do have the rest done, work on 41 and 42.